Welcome to lesson 6.5, prove triangles similar by side, 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 and side, angle, side. So in this case, we're going to be looking at theorem 6.2 for the side, 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 and then theorem 6.3 for the side, angle, side similarity. So let's start up here with 6.2, our side, side, side similarity theorem. Says if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So if the ratio or proportion, I should say the ratio of AB over RS simplifies to the same thing as BC over ST and CA over TR. So if all three side relationships, the corresponding sides, are proportional, then the triangles are similar. So let's say each of these simplified to 4/5. These two triangles are similar. So let's practice that idea. Example 1 says, is either triangle DEF or GHJ similar to ABC? So in ABC, I have a side of 8, 12, and 16. So let's first look at DEF here. So DEF, what we want to do is check corresponding parts. So I'd want to visually flip this triangle so that the E was on top, so it would correspond with the B. Then D would correspond with A, and F with C. So side AB on this triangle, we're checking it with DE on this one. So if we do that, AB was 8, DE was 6. 8 over 6 simplifies to 4/3. So one way I can know if I'm matching up the right parts, I want to take the shortest side off of each. That would be the corresponding. So to know that they correspond, AB is the shortest on this one, DE is the shortest on this one. Then you do the same with the longest sides. So CA is the longest. And on this one, DF is the longest, or FD. So we do CA over FD. 16 over 12 also simplifies to 4/3. And then we'll use our remaining sides. So BC, 12 over EF of 9. So 12 over 9 also simplifies to 4/3. So my corresponding sides are all proportional, meaning triangle DEF is similar to triangle ABC. So now we need to check triangle HGJ or GHJ. So in this case, we're going to start with the shortest sides again. AB is our shortest here over GH, the shortest on this one, which would be 8 over 8 simplifies to 1 over 1. And then we'll do the same with the longest sides off of each. So CA over JG, so 16 over 16 is 1 over 1. Now we need to check our remaining sides. So side BC over HJ. So that'd be 12 over 10, which simplifies to 6/5. So one of these ratios is not proportional to the others. So triangle GHJ is not similar to triangle ABC. So in the next one, using algebra to find the value of x that makes triangle ABC similar to DEF. So in this case, I knew in ABC I had a side of 4, side of 8, and a side of x minus 1. And then in DEF, I have a side of 12, side of 8, and a side of 3 times the quantity x plus 1. So when I'm setting this up, I want to use a proportion and use one of the sides that has x. So it's easier in my mind to use the x minus 1, so I'll use that. So in this case, I know AB is supposed to be corresponding with DE. So on one side, I'll do AB over DE, or 4 over 12. Then On the other side, I want to use my side with the x on it, so x minus 1 over 18, corresponding parts. So our proportion, 4 over 12, equals x minus 1 over 18. We want to cross multiply, so 18 times 4 is 72. 12 times x minus 1 gives me 12x minus 12 when we distribute. Add the 12 to each side. 84 equals 12x. Divide by the 12, and x equals 7. So the value of x that makes these triangles similar is when x equals 7. Then in example 3, A and B, says which of the three triangles are similar? Write a similarity statement. So for part A, that's what we want to check. So part A, let's do that first. So first thing, I want to try to match up my shortest sides. So on this triangle, LM is my shortest, and on this triangle, RS is my shortest. So LM over RS is 5, 6. Now if I use my longest sides, LN, 26, and ST, 33. 26 over 33 does not simplify to 5, 6. So I don't even need to check the other side. I know those two triangles are not similar. So now I'm going to check triangle LMN with triangle XYZ. So in this case, shortest sides again end up being LM over YZ, which is 20 over 30, or 2/3. Then we do the longest sides, LN over XY, 26 over 39, simplifies to 2/3. And then our remaining sides, MN over XZ, 24 over 36, both can be divided by 12, simplifies to 2/3. So in this case, all the sides are the same ratio, same proportion, so we know triangle LMN here is similar to triangle YZX. Then in part B, the shortest side of a triangle similar to triangle RST is 12 units long. Find the other side lengths of the triangle. So for the shortest side, we knew the shortest side was 12 units, and the shortest side of RST is RS here, 24. So I'm going to put my shortest side on my unknown triangle over RS. So 12 over 24 equals, and then if I'm trying to figure out my other measurements, I could then take my missing pieces. So I know 12 over 24 for both. To figure out the middle side, well, RT is 30, so I'd have x over 30. To figure out my longest side, ST is 33, so I could do y over 33. So we're setting up a proportion for both. Then you want to cross multiply and divide to solve for x and y. So x would be 15 and y would be 16.5. So our three side lengths then would be 12, 15, and 16.5. And then our other theorem, theorem 6.3, the side angle side similarity theorem. And this theorem states, if an angle of one triangle is congruent to the angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. So if we knew angle X was congruent to angle M, the sides we care about are XZ and XY, and then MP and MN. It's the two sides that create or include that angle. So the rule is, if our angles are congruent and the two sides are proportional, then the triangles are similar. So let's look at example 4 here, talking about a lean-to shelter. So you're building a shelter, or a lean-to shelter, starting from a tree branch as shown. It's asking, can you construct the right end so it is similar to the left end using the angle measures and lengths shown? So here's the part that they started with related to the tree. We had a measure here of 6 feet, a 53-degree angle, and a 10-foot measurement. Then, for the part that they're asking about, we had angle A of 53, side AB of 9, side AC of 15. So let's see what we already know. Well, we knew the measure of angle F on this triangle is congruent to angle A on this one. So angle A and angle F are congruent. We need to see if the two sides then are similar. So we need to see if FG is proportional to AB and FH and AC. So let's check our shorter sides. FG over AB. 6 over 9 equals 2/3. Check our longer side. FH over AC. 10 over 15 also simplifies to 2/3. So I have similar sides that are proportional, and I have the congruent included angle. So by side angle side, the triangle FGH is similar to triangle ABC. So yes, you can make the right end of the shelter similar to the left. So this box here, concept summary, is taking our different pieces, our angle-angle similarity, our side-side-side similarity, and our side-angle-side similarity theorems, and just organizing them for you in one spot. So these are the 3 different similarity pieces we'll be looking at. So then in examples 5 and 6 here, they just want us to say which method in 5 would we use to show that the triangles are similar. So triangle ACB and triangle CED, or DCE. So right away, I know angle ACB here and angle DCE are congruent because they're vertical angles. So I have congruent angles right there. Then I have 2 sides that include the angle, 2 sides that include the angle. So I'm going to check to see if I can use side angle side. I don't have any other angle markings, so I know I can't use angle angle, and I don't have my 3rd side lengths. So I know I can't use side, side, side. So my only option is to check for side angle side. So in this case, side AC here, the longer side, should be over side CD, the longer side on this one. So 18 over 30 simplifies to 3/5. And then BC, the shorter side, over CE, the shorter side, 9 over 15 also simplifies to 3/5. So the sides are proportional. The included angle is congruent. So yes, these are similar by side angle side. Then example 6, parts 3 and 4, again ask us to explain how to show that the indicated triangles are similar. So how can we show that triangle SRT is similar to PNQ? Well, in these 2 triangles, we were given the right angles, so we know angle R is congruent to angle N. Then I have 2 sides that include that, 2 sides that include that angle, so I'm going to check for side angle side. So SR here corresponds with PN here. So SR over PN, 24 over 18, simplifies to 4/3. Then we can check RT over NQ, 28 over 21, also simplifies to 4/3. So how can they do this similarity statement? They would use side angle side. In 4, we're looking at triangle XZW and triangle YZX. So what I know right away is angle WZX here and angle XZY are both right angles, 90 degrees. So they are congruent. So I know angle WZX and angle XZY are congruent. Then I have two sides here, but those don't include the angle. But I do have a third side on this triangle that does include the angle. On this triangle, I also have three sides, so I could check for side, 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 but I already have an angle here, so I'm going to check for side, angle, side. And in this case, I'll match up my shortest sides. So shortest side on the one on the left is XZ, shortest side on the triangle on the right is YZ. So XZ over YZ, 12 over 9, simplifies to 4/3. Then I'll use my longest side, WX, or the other side, 16. And then we need to match it up. So if I use WX at 20, that'd need to go over the 15. Or if I use the 16, that'd go over 12. Well, either way, 20 over 15 and 16 over 12 both simplify to 4/3. So in this case, you could use side, angle, side, or they could have used side, 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 depending if you use the angle here or if you just check the ratios of the three sides. So on that one, we could use two of the different